I mean the command line. This is, I think, the best interface on the earth. And maybe does not suit all needs, but I could just stick with that interface and I will solve most of my problems. Maybe not the lecture, okay? But everything connects with programming, with calculation, my research, command line is enough. Then in the 80s, so for 50 years ago, the idea of Windows became available, popular, okay, because it was the idea exists on the market, exists on the as an idea or some very primitive realization even in 60s, okay, but in 80s it became available for almost everybody, and we are living with that, okay. At least my laptop I'm facing it now, talking to you, is based on the oh, by the way, Microsoft Windows today due to some demo, but it does not matter. It could be Mac OS, it could be Linux based, it could be even Android based. All of them are WIMPs, okay, Windows based idea. Does something change up to today? Yes, or partly, okay. The change is the fact that we are facing or we are using different equipment, okay. So mobiles, tablets, TVs, of course, PCs again, or still from 80s. And the solution to that different hardware behind it is the web-based applications, okay. So HTML and surrounding. So HTML and CSS, this is the user interface in many cases. Of course, we still have some native interface available, but it is sometimes used, but not so often. And the only solution that glues things together is HTML5. Okay, so let's make the story simple, not go into details. So how it works, or what is, I think, interested, what I want to point your attention to that idea, because HTML is known by everybody. But just notice that our modern web-based applications, so HTML, CSS from the front end, from definition of the user interface structure, and JavaScript as the language for moving things together, okay, we can notice that the browser, today browser, is a kind of the mini operating system, really, okay, because the web pages are really programs. They contain real executable code. So web pages are it's a software, really. It's not just a static software. It's something quite huge software. It communicates with other software. Just an element of web microarchitecture approach. Okay, so we have software running in a isolated environment in web browsers. The other change or the other movement we can notice more or less in the same time, and it's really interconnected, is the movement in hardware and the way how we are using the idea of computers. So we have in 60s central systems, huge rare computers, then a discovery of PCs. Okay, so companies like IBM, companies like Macintosh, and the idea that we have one computer per one person. Okay, it changed a lot. Then in 90s, internet, so connecting things together, and the business that is using the internet to communicate each other. And we have what we have now. Okay, so extra to that idea is mobile technologies, and of course cloud computing. On the other hand, I think that cloud computing could be also seen as a kind of the central systems with some problems of central system existing in the past. Okay, but of course, slightly different. If I will have time, I will try to explain it in more details. So let's look in some more formal definition of NIST, what is cloud computing. It's a really long definition, so I want to point your attention to some elements that I have marked them in red. I think they highlight the most important aspects of cloud computing. So on demand, this is something which is really the effect of techniques, but this is really what makes something cloud. Okay, that we can access to some resources on demand by network. Okay, so we have somewhere, it could be nearby in the next room, it could be in the next building, it could be on the other side of the world, a set of hardware, okay, computers, networks, etc. But you using some simple, in most cases web-based interface could select, configure that resource. Okay, so select, I don't know, 2 CPUs, 2 terabytes, let's say Linux plus Python stack, and maybe some MySQL as a service. Just wait few seconds and they are rapidly provisioned to you, okay, without minimal management effort and just almost no human interaction. Humans would design it, humans could control it, but it does not require somebody that is just going to some hardware, turning it on, turning off, installing. Most of things are done automatically. So how it is possible? Okay, I will try to explain it to you that it is like it is and why it is possible. So why clouds are really used? I think the answer, or there are 2 answers. The one answer, because it is possible, okay, and let's say I am the most interested in that fact as an engineer, but there is a second important aspect, because it is cheaper than previous approaches. Okay, so huge data centers nowadays, they are much larger than past systems. Okay, we have data centers in 80s and 90s, but today data centers are totally huge compared with previous ones. Such companies like Google, Amazon, for example. And to make them cheap, they are automated. Okay, so they are far away from us as developers. Okay, very often due to some technical problems or features of sending energy through wires, they are close to where power is generated. Because what is the effect of computation? Okay, it sends some data to the other data, but from the physical point of view, from the external world, it just converts electricity to heat. Okay, so it requires a lot of electricity. That's why they are very often close to power generators, because transmission of electricity is connected with losing some of the energy. And the second problem is the heat, which is outside generated from such, each computer, of course, but from such huge data centers we are talking of. This is a huge problem. Okay, so also the problem how to deal with that heat. Very often, for example, data centers are close to rivers because they need water as a way to just put the heat to. Okay, so rivers, lakes, that kind of stuff. Because of money, of efficiency, they are very highly packed. Okay, and technically it is possible. Okay, because we have virtual machines, we have virtualization that provides isolation, okay, and that provides a capability of running different operating system on one hardware, okay, and this is, let's say, the core of our lecture. And the business, the money, is the efficiency in the sense of keeping them busy, okay. Of course, they are not overloaded fully, okay? So it is always avoided to overload them in 100%. They are busy, let's say, in 80, 90%, what makes really money because of the scale. Okay, so this is an example. We have here some numbers, but do not stick to them very closely, okay, because cost of the large data center is not true for today. The data from let's say around 8 years old here. I will later on show much more current values, but what is a really important message from that slide is that when we compare prices of let's say megabits per second per month, okay, large data center is around 7 and even more today dollars less than it was in the previous approaches with smaller data centers. Okay, more or less the same with storage, and especially important, very costly element of all hardware equipment are humans. Okay, and now since the humans are administrating a large number of computers per one person, it is much more, the cost is really smaller than that. That is the reason why cloud is winning, because it is cheaper. Okay, so, and this is something that we can see in supermarkets and everywhere. Okay, that if putting different small things together makes the company making money because they are saving money on the scale. Okay, and this is the scale idea, and we are using it as developers, and we have to face some problems, new problems even. Also, old problems still exist, but new problems are arise due to cloud. Okay, nice picture. And you can notice that there is nobody. Okay, I never been in a Amazon data center or that kind of stuff, but once I was in a Poznań Supercomputing Center data center, and it looks more or less the same. Maybe the number of computer was less, okay, but the huge, terribly huge room, okay, locked, and as we have been on the visit, so the head of the supercomputer center opened it especially for us, okay, and let us to see what is inside, and there was just a noise generating by computers, lights, and nobody there. Okay, so this is the, by the way, the Poznań Supercomputer Center is built on the bank of the Warta River, okay, just to solve the problem of heat. So what are key benefits of clouds? Machines busier. Why busier? What is important? Just look at your computer and see what is the percentage of CPU used by it. In most cases, something like 2-3%. Okay, so 97% of the power of your PC is not used. So it's waste of hardware. Okay, so it could be quite a good idea to sold that power to somebody else. This is the idea behind the cloud computing business. It is possible because applications are nowadays much more standardized and they could be automatically managed. Okay, so as an effect, we have less admins. Okay, so power consumed near generators, so less wastage. Data centers runs hot, so so cooling is a problem, but when it's kept together, maybe it is less, more cheaper. And you as a user of such equipment, such solution, you could rent resource rather than owning them. Okay, so in many cases it is also cheaper. So it changed the usage of computers, and really the scale is the most important element. So everything could be accommodated on demands. And we can therefore deal with a really huge aspect, size of data, okay? And we can process the data in a massively parallel way, okay? Because we have easy access to a huge number of processors, and we can even buy processors per hour. Okay, so if I need calculations for some reasons, I'm buying them, then I'm not using them, or so I'm not paying, for example. So this is something that also requires some change in the style of programming. But it is enabled mostly, or the most low-level technique is virtualization. Okay, so soon I will switch to that aspect. This is the core of the economy, of the scale. Okay, so doing more with less. Of course, it requires standardization because if we have elements that are used, at least from the outside world, in the same way, it allows a reuse and share. Okay, so we can have applications that connect with other applications, and now it is much easier to integrate them than it was in the past, and they are very automated. Okay, so therefore cheaper, optimized, very often more secure. Okay, because things were tested by others. So this is something that makes it running and busy. Okay, so the main aspect, which I think is the most important, at least from my point of view, okay, maybe for economists, the other aspect would be more interested. But for me as a technician, the most interested is virtualization. And we have different aspects of that word. For example, what we are doing now, the distance learning, it could be seen as a presentation virtualization. Okay? I have presentation on my PC, and due to cloud, because Zoom could be seen as an element of the cloud, and it's really a cloud service, you have an access to presentation of my own PC. Okay, but this is something which I don't want really to talk about. It's of course important, but most of things like desktop, also presentation virtualization, is possible due to server virtualization. Okay, so due to the idea of virtual servers, this is something what is running somewhere deep inside in all data centers, and of course, as you know, you can run also virtual servers in some versions on your own laptops. Of course, it requires some storage, but it is connected with server virtualization, some network, but it is again connected with server. It's one of the aspects of the software that we have in virtualizations. So what is a server virtualization? It's a technique, it's a methodology of dividing the computer, piece of hardware, server, into multiple separate execution environments called virtual machines. So we have one hardware, such equipment exists in the lab 229. Maybe you have had, or we will have some meetings. This is a picture which is connected with operating systems. I hope that during the very basic lecture and during your engineering study, it was discussed with you what is the aim and how the operating systems are working. At least at our universities, our IT students have such set of lectures, mostly called operating systems or something like that. So to make things simple, the aim of operating system, or the idea behind operating systems, are layers. Okay, so the aim of operating system is to build a software API, a piece of software endpoints that separates applications from the hardware. Okay, so if you as a coder developing some stuff, and I don't know, for example, C++ or anything else, and you want to, I don't know, access the files, okay, any files on some hard disk, you don't have to bother if it is what is the kind of the hard disk used by the user, or maybe this is a virtual hard disk, or maybe this is a physical hard disk, okay, or maybe this is the CD-ROM, whatever. Still, the functions are the same. Why? Because operating systems gives a set of functions, for example, Windows API, that allows you as a developer of your application, or maybe allows some library for Python that separates the Python stuff, open functions, from some real hardware. Okay, so you don't have to bother the structure of files, if it's NFS or maybe other file system. It does not matter for you as programmer because you have operating system. So operating system makes you a, let's say, I will use that word, but it's maybe not the proper, the virtual representation of hardware for application. Okay, so it deals with the all the hardware stuff, input-output devices, with sharing the memory, okay, and with accessing the CPU. Okay, we have a multi-processors processor environment nowadays, and the basic aspect of operating system is to giving access to different processors, the same CPU or the set of CPUs. Okay. So what is the idea of virtualization? It's just to add a next layer. Okay, so we are adding a layer between operating system and the hardware that makes the hardware to be virtualized. Okay, because just look, what is the aim of the driver in operating system? Okay, is to hide to you the details. Okay. So, and you can notice that there are something like virtual devices. Okay, you have, for example, virtual disk. Okay, this is a piece of software. Virtual disk were popular in 90s when hard disks were slow. Okay, so from the point of view, even for the operating system, it is a hard disk. Okay? Write the read from them, but it is not a hardware from a practical point of view. Okay, so the aim of the virtualization is to add a next layer to play a role of the super operating system. It's very similar in many functionalities to the operating system. Okay, just a really modification of some existing operating system, and that's all. So it's, technically speaking, not a very sophisticated idea. You just take a Linux, add some extra features, and you have a hypervisor. This is the name of that software. But it is not a new story. I mean that, as you can notice on this slide, the virtualization, the idea of virtual machines were introduced in early 60s. Okay, so many years before your birth. Because IBM have a problem with their hardware because it was very expensive, and they wanted to make them to be more used. So virtualization is the solution. It was given away to personal computers in 80s and 90s. It was not used. It was not hot topic, let's say. Like, of course, IBM was still selling it, and some rare cases people were using it. But in late 90s, due to mostly the VMware company, this is the name of the company, and still this is the name of the software products which we are using for virtualization, it became hot again. Okay, the VMware was working with virtualization of Intel 860 architecture, so the architecture which was or still is in most cases, but not 100% as it was used for in PCs. Okay, so they add a possibility of virtualization to personal computers, and soon hardware became cheaper and cheaper, and more powerful, and suddenly the PC became so fast as a huge IBM stuff. Okay, so it was used as they started to be used as servers, and again the need of virtualization as it was in 60s became important, and now the virtualization of PCs is or of Intel architecture is the key component of cloud computing. So how it works? So most of the ideas and names I'm using on my slides, and in most cases these are names still used. Maybe the virtual VMM, a virtual machine monitor nowadays is called hypervisor mostly, but other names are still used. It's coming from the paper from Popek and Goldberg from '74. Okay, so still far away in the history. So virtualization is based on the software. We have a virtual machine monitor. Okay, so this is an additional layer between an operating system and the hardware. And that's all. This is, from general point of view, this is a simple idea. Add a next layer between operating system and the hardware, software layer that represents the hardware in the same way. Okay. In practice, the performance is achieved to the idea that, or to some techniques that I will discuss just on next slides, that most of the instructions, the binary instructions that are running in your application or in your operating system are executed on the real hardware on the fly without any intervention of virtual monitor or in any intervention of the hypervisor. Just that hypervisor deals with some important aspects, I mean accessing the hardware. Okay, so how we access the hardware in computer systems? Two tricks in general, but in Intel it is accessing the input-output instructions. Okay, so you are just using the interrupt instruction in the semi-assembly language and an assembly language, and you use the in-out instructions. Okay, so just to take them, okay, trap them, and that's all. And it could be done, and it is done. The Popek and Goldberg distinguish two types of virtual machines. Okay, the names they gave to those types are strange, type 1 and type 2. Okay, but still that division is important. However, very often now we have something which is somewhere in the middle. Okay, so maybe it is not always clear nowadays, but I will explain it soon. Okay, so the software, the hypervisor, is a piece of the software, and in practice, this is an operating system based. It's really some distribution of Linux with some extra features, or some modified Windows, or just you can even add to Ubuntu some features or to other distributions, and now it becomes a hypervisor. So what is the difference between type 1 and type 2? It is shown on the slide. So type 1 on the left-hand side, a hypervisor, is connected with servers. Okay, so it is a rare case that you are running it on your own PC. Type 2 is connected with PCs, and probably you have been using them in your real life. So type 2 is, for example, VMware Workstation or VirtualBox. Type 1 is the VMware vSphere or Xen. Okay, these are two examples, but of course not the only. We have solutions from Microsoft, and we have key VMs that are somewhere between these two approaches. We have also nowadays much more sophisticated stuff as the idea of emulation of processors. Okay, for example, on my not that laptop I'm now running, but on the other laptop, I have the RISC processor, but I could run 86 architecture due to translation, the kind, and virtualization, really. But I'm not talking about, I'm trying to make the words more simple, okay? So type 1 hypervisors is a piece of software like VMware vSphere or Xen you are installing on the hardware, on the bare metal, how we are naming it nowadays. Okay, so just like Linux system, it's mostly, at least these two are just Linux systems, by the way, with some mods, and then you have a software that you can install next layer, so any operating systems on that operating system as the hypervisor is. And the second stuff is placed slightly differently. Okay, you can notice that it is not placed between the operating system and the hardware, but it's placed between operating system and operating system. Okay, so the virtual or the hypervisor of type 2 could be seen as a normal application that you are installing on your operating system. And it provides you the capabilities of running some virtual machines, I mean operating system with applications inside. So it is different because they are used for different purposes. But what is nice that the images, of course, VMware and VirtualBox on one hand uses different images, but they could be converted from one to the other type without any problem. And you can just prepare the virtual machine on the type 2 hypervisor and run it on the type 1 hypervisor. This is a really nice side effect of virtual machines, that you can move your system from one place on the earth to the other without any problem, just by moving data. Okay, so this is a very nice side effect. Of course, the solution, the left solution, is more effective in the sense that it does not require some additional layer than the native operating system. So it is slightly faster, but it is more flexible, the type to be used on PCs, okay, because PCs are mostly used just to play with them, to run some graphical user interface applications, not just to run virtual machines, but sometimes virtual machines for testing purposes, for example, are needed. Okay, so we have type 2 and type 1, and you have some examples given here. Why it is possible, the virtualization? So what is, I will repeat myself, the aim of the virtualization is to share the resources, the hardware resources. I mean CPU, and this is the main subject of next slide, the memory and external devices, mostly the hardest, the network. Why the CPU is the most important, really? Because CPU is easy to be shared. Okay, because if you are using memory, it is almost impossible that the memory will be shared among different virtual machines, because the memory, you have to be accessed. And when you have data in the memory, they have to be in the memory. Okay, it is impossible to have two different data in the same memory. Okay, in the same cell of the memory. But CPU is slightly different due to the fact that most of applications are not using CPU all the time. Okay, again, just look at your PC. It is running probably even 100 applications at the same moment, but the usage of CPU is some like 5%. So again, the next 2,000 of applications could be run if the memory will be enough. So the CPU, in many cases, but not all cases, but in many cases, especially in the web-based applications, usually the CPU is used rare. Of course, it is used when we have a large number of users. So what are the techniques to deal with CPU virtualization? We have three techniques. They are in red, and I hope you have some time to read them on this slide. So we have a binary translation. We have para-virtualization and hardware-assisted virtualization. So let me explain what they are and how they could be used. Okay, so I hope that you have some time to look at this picture. And binary translation. Binary translation is connected with VMware because it was their original idea, and it was the technique they used for many years. Then it changed to hardware-assisted virtualization because it is better, but I will explain it soon. And I don't know, how are you aware of that Intel processors architecture? But maybe you have heard that we have rings there. And for example, Windows is running in the ring 0. And I mean Windows, I mean all the drivers, for example, and the core of operating systems. And applications are running in ring 3. And when an application just calls something from the operating system, again, because I was explaining it, using int command or in-out commands, these commands are trapped automatically by the processor. This is the idea in the construction of modern processors. So all the data are placed on the stack, and the driver that is responsible for dealing with that interrupt, for example, is running in the ring 0 and doing the hardware stuff. Then everything returns, so the data are get from the stack, and again application goes further in the ring 3. So switch between application and operating system is done by hardware. So the idea of binary translation was just use it, since the ring 0 is needed for the lowest level of aspects of operating system, I mean the hypervisor. Therefore, the operating system is now in the ring 1, which is mostly not used in Windows. Okay, so this is just that trick. So it more or less behaves like normal operating system, or the application is running like operating system, so just accessing the hardware directly. Okay, so it does not require any additional stuff. But from time to time, the binary translation is used, so sensitive instructions are tracked, and a piece of the software, I mean the hypervisor, is using them and emulating the hardware. Okay, so making the representation of hardware in a single way. Okay, so it's again the aim of the virtual again is, I mean, like operating system. Okay, because it requires some drivers to deal with hardware. It requires to share CPU, but not among applications, but not among different operating systems running. But more or less, it is exactly the same problem. Okay, so binary translation is a very clever trick because most of the code is directly running on the hardware. Therefore, it is not costly in the sense that some translation is required. Only few set of instructions, only sensitive instructions, as input-output instructions, now require some extra running, but they are not called very often. So the cost in the sense of the overhead for the CPU is not high. And we have then, okay, this is what I was talking about, just for you for the reference. And the second technique, which is called Aspara virtualization, or operating system assisted virtualization. It is connected with Xen. So Citrix company behind. So the Xen virtual machines were originally based on that technique. The trick is why to try to monitor that calls to hardware maybe much more clever was just to inform operating system by modifying it that we have a next layer of drivers, let's say. So we have a virtual machine monitor, and not to access in-out directly, but just normal calls to sub-element of operating system as virtual machine monitor could be seen. So now it is much more closer on one hand to the real, I mean the situation without virtual machine, that operating system is running on the ring 0, the same hypervisor, but what is stated here in red requires modification of operating system kernel, because operating system kernel has to be modified and some hardware calls are replaced now to the calls to the next layer of software, I mean virtual machine monitor. So it is very effective, much more effective on one hand compared with the previous slide, with the previous solution. On the other hand, okay, we can notice big limits. Okay, so in practice, it is connected only with Linux. Okay, because Linux is an open source stuff. Okay, so that's why, since it requires a really deep operating system kernel modification, the portability is quite poor, but it has lower overhead. But fortunately to us, we have nowadays the third solution. And the solution is more or less the same as it happened when 286 architecture, especially 386 architecture, were introduced. Okay, so rings were introduced, not only rings, but virtual memory and other stuff were introduced to Intel and PC-based computers. So companies like Intel noticed that virtualization became popular, so they extended their architectures by adding lower rings than 0. Due to history, it is called ring -1. Okay, and now all the sensitive operations running in ring 0, like in-out, are trapped automatically, are trapped by hardware, not by software. So they don't have to be monitored, etc. It is much easier than it is in the solution coming from VMware. Of course, VMware and Xen are now using that stuff, but that stuff requires better CPUs. On the other hand, I don't remember when I have a computer without these extensions. Maybe it was 15 years ago, maybe 20 years ago. Okay, so it's something that exists in not all computers. It's not true, but in all more expensive computers. Okay, not the cheapest one. So the idea is very simple on one hand. On the other, of course, very sophisticated, but because it requires the changes in the architectures. But now it's more or less the same, like what is done between ring 3 and ring 0, and is trapped by hardware. Okay, so this is VTX technology from Intel, AMD V technology from AMD, and this is what it is really nowadays used. Okay, that makes the hardware assisted virtualization possible. That makes the cloud to be possible, and this is the core of all virtualization nowadays. So we have an extra operating system that is like or is based on normal operating system, let's say, that plays more or less the same role as normal operating system, but the only difference that it contacts with operating systems. Okay, therefore operating systems are running on that software, I mean hypervisor, are isolated, and you can run more than one operating system on one hardware, even an operating system of different types. So it allows to utilize the usage of physical servers and enables portability. What I mean portability, because the hypervisor is mimicking the hardware, so we have just one type of, or two types of network cards, virtual network cards. Okay, so I could just freeze the memory and hard disk of my virtualized operating system, move it to the other side of the world by network, and run somewhere else from the moment. And it will run because it will be seen for that operating system that it is exactly the same hardware. Even it's not exactly the same hardware. Maybe the network card is different, the hard disk is different, because we have the virtualization layer. Okay, so it's like in English. Okay, you can use English almost everywhere on the earth. Okay, this is like a virtualization between your native language and my native language. We have English. Okay, and this is the solution, standards. And of course, it makes administrator life easier, much easier, because everything is standardized. Of course, this is not the end of the story. This is not the end of our lectures, because we have newer techniques, but this is the subject of the next lecture. Maybe I will not talk about security of virtualization, because security is something which I am not an expert in, but I will spend some time on showing you how the administrator life is easier. Okay, so just give me a second. Okay, I will log into the system, but I have to rememberize the password, so I will not talk to you for a few seconds. Okay. I hope that I have managed to remember the password. Okay, it's connected. Okay, so now I will change the screen. Okay, so what you see now, this is the not that one. This will be this. Okay, maybe that one, vSphere. Okay, this is the vSphere client. Okay, this is not something hot and new. Okay, I was using. I'm not using it nowadays. It's for the last 15 years, something like that. So this is nothing very hot, but it will show you what is the next step. Okay, so this is the computer which is running in the building C3229. Only one computer is now connected, since we have not bought license for connecting two servers, because we are not using them extensively now. But of course, it is possible to have more than one, and it's quite old computer, so just used because it is used. But you can notice how many different virtual machines we have here, and I could just press them with, okay, maybe something which is not dangerous. Okay, oh, this is our conference system. Okay, so I'm selecting that computer, turning the console. Okay, and in a few seconds, if I will manage, you can notice that I could be there at the front of this computer. Okay, if not, I could switch to the other computer. Okay, so maybe this is mine, maybe to Henryk Maciejewski 1. And you can notice this is Windows. Okay, so I'm running the Windows, and it's like I was there. Okay, I could press buttons, work with that, etc. I can see what it is, so I can just by pressing buttons see that I have access there to CPUs, the amount of memory, the IP. Okay, I can notice that it's really doing nothing, not using the CPU. It is using the memory, because it's always using the memory, especially Windows. So I see the hard disk attached there, and I could do different things. Maybe I will not be doing, okay, because it is used for didactic purposes. So I'm now turning to the other machines. It's not running. You can notice that I have some memory, CPUs, and everything could be changed on the fly. Okay, so maybe I will give her just 6 CPUs. Why not? Maybe memory is too much, so maybe 6 GB will be enough. Okay, I have now hard disk connected to it, but I could add a new hard disk. Okay, why not? So hard disk, where is the hard disk? Serial parallel, some other device. Okay, I have hard disk. Okay, so I could create a new virtual disk. The size of the disk, maybe I will not create to make problems. Network cards, maybe I need a second network card. Okay, so I'm selecting the second network card. I have some external, so you can notice 3 different virtual cards. Okay, and I could select networks, and only one network is the real network from the outside world, and the others are just created by me, virtual networks. So I can do anything just by pressing buttons, okay, and using a dedicated application. And the application is running locally on my PC. Unfortunately, the application is just Windows-based one, okay. That's why I have to switch today to the Windows computer. Why Windows? Because it was popular to be used with Intel processors, and that's why Windows, and nowadays is done slightly different, but I will show it later. So it is easy to change any parameter. So just by pressing buttons, okay, you can even monitor it just on the fly. So maybe I will switch to the Sasanka again, see the performance, okay, and see the number or whatever was used, when it was used. So all the data are recorded. Okay, this is the paid software. So maybe the free software has less capabilities, I mean the Xen one. So now I will switch to the next application, which is Xen Center. And this is for free. I mean, the virtualization and everything is free here. And this is our system. Okay, you see it, I hope. The Xen Center should be seen now. And I have here more than one computer. You can notice via host. So how node 08, okay. I have a group of hosts here somewhere, maybe. Okay, I could, that pool is a group of hosts with exactly the same hardware. So I could really move virtual machines on the fly without turning it off. Okay, so I have connected to it. So I have 12 of 13 of nodes here I could access from my PC. And okay, the user interface is slightly different, but it is more or less the same. Okay, so I have the console. Okay, this is our project GitLab server. Okay, so I could connect to it. Okay, I'm just running some comments on the computer, physically on the computer, the console. If the network is broken, it's not responding, it is here. Okay, and I have more or less the same feature, so I can notice how many memory is used. Even I could have a more global view on the whole node. Okay, and you can notice what is our main problem. Not too much memory. Okay, the only memory is problem. So this is, I have all virtual machines, the amount of memory used by them. I could use to the storage, so the hardware that is connected with that node, and then I'm reconnecting it to the virtual machines, see the networking, 2 physical external cards, 2 physical networks. Console, I have seen you. So again, I could, for example, change some, okay, maybe something not running, okay. So I could change the number of CPUs, maybe 7 will be okay. I could change some parameters, how it is started, if, okay, the GPU will be available in that system. I could access the GPU to that virtual machines, etc., etc. In the other view, like here, I could edit the memory. Okay, so maybe 8 gigabytes is too much. I will give less to it, etc., etc. Okay, I'm not pressing everything because I don't want to destroy. I could start it anytime. Yes, I'm starting that. Oh, it was a stupid idea. So if it will start, I will kill it. Slow, because it could cause some problems. Okay, this is a stupid idea to show some real systems running. Okay, so I will try to come back it soon. What I was not showing there, but of course it was also possible in case of VMware. It is possible here. I could create a new virtual machine. So, new virtual machine. I'm selecting some templates. Okay. Other installation media, next. So I'm giving the name. I'm selecting the image I will start from. So Ubuntu, for example, that is the image there. I have different images, you can notice. Next, I'm selecting the hardware. So I am selecting on which server, the memory, accessing CPU, storage, networking. So I will cancel it. I will stop it. Okay, so force shot. Yeah. Oh my God. Okay. So it is easy for me to administrate, and we are co-administrating with colleague, and I'm just spending an average 10 minutes per day to administrate it. So it is very easy, simple, and just creating new virtual machines, just pressing buttons. The only limits is the hardware we have, and in our case, mostly memory. Okay, it is something that we are running off quite soon, but this is the case we are dealing with, the problems we are dealing with. So it is easy. Everything is on demand and done by API in practice. Why API? Because this is the local software that is running on my computer, and it sends commands to the VMware, to the Xen, whatever is on the other side. Okay, so just the API could be reused, and I will come back to it soon. Okay, so since time is passing by quite fast, I will come back to my slides, okay, and skip some of them. So what we have now, okay, so that 86 virtualization with para virtualization and with hardware supported virtualization, and the stuff we were talking about, that we are making everything available as a service, or service-oriented computing, make cloud computing possible for the last 12-13 years. So in cloud computing, everything could be virtual, okay? Software, databases, operating systems, storage, networking. Everything is on demand. Just, you have noticed, just like pressing buttons, okay? I could just change everything on demand in the limits of my very, very small cloud, okay? But if you can imagine just Amazon or some other companies, okay, so they are unlimited compared with us resources. And therefore, it is possible to create a massive scale application. Most of the software I was showing it to you today is free. The system could be geographically distributed. Okay, I'm now in all mountains, not in Wrocław, and the hardware one was in D2 building, the other was in C3 building. So they are geographically distributed, and I could manage them. Quite easily. This is the cloud software that makes our life easier. And since everything could be monitored, the number of the usage of everything. I was showing it to you that we can see the number of megahertz used, the number of memory used, the hard disk used. You can create some billing system, just turn it into money, or just inform your bosses that that branch of company is using that amount of resources, the other amount. And this is easy to get such statistics because they exist inside the system. So monitoring and pay-as-you-go model is quite important. Even if it's within the company, very often in not IT companies, the IT branch is recognized as a branch that's eating money because hardware is costly. Okay, but now you can show to your bosses, okay, it is costly, but it is used, okay, and where it is used and how it is used, so you can have some internal money given to you to buy new hardware. But of course, you can do it outside. In case of cloud computing, we have a lot of acronyms, okay, that are mostly ASs, okay. Some of them, of course, like SOAP was explained by me, but what does the ASs means? As a service, okay? So we have infrastructure as a service, and that stuff I was showing you, I mean that Xen and VMware stuff is infrastructure as a service, okay? That's some infrastructure, I mean some operating systems, some hardware, virtual hardware could be accessed as a service, okay? So, for example, Amazon Web Services, this is the example, but also our very small cloud university is an example as infrastructure as a service. And you can just buy it quite easy. And what is important, that prices are quite low, okay? And this is an example of prices for 218, that 1 hour of the smallest virtual machine from Amazon was costed less than 2 cents per hour. Of course, if you wanted to have something bigger, it is much more costly, but still, if you need something for a limited number of hours, this is the perfect solution. So you are pressing buttons, paying, and getting access within 5 minutes, okay? And the prices, especially in the past, not today, okay? The prices are not going so much lower as it was in the past, but still each year it is cheaper. And that slide shows that prices are cheaper, but not so fast as it was in the past. For example, 2 micro in 2012 was 1.4 cents, now is 1.1. So, okay, slow difference, but not going so fast down. But when we look, for example, for 64 CPUs, and now it's only $3. So the downgrade of prices is still noticeable. Okay, so it's not worth to invest in the hardware in most cases, not in all cases, but in most cases. Of course, prices are changing each year, let's say, or even each 2 months. So don't stick with numbers, but what really I wanted to pay your attention that the prices are going down. So what is the cloud computing compared with traditional on-premises computing? It's just giving an element of your technical stack to be managed by others. Okay, so in traditional approaches, you as an administrator have to deal with all layers, from the application to the hardware, okay, with everything. You have to control it, you have to update it, install it, etc. But in the cloud, you can make a decision what is the area of your own responsibility and the responsibility for our company. Okay, you have to pay it somehow, but sometimes it is cheaper, and even huge companies, even with hardware, are using external clouds because you don't have to bother. Okay, if I'm administrator of the data centers, I have to bother with the problem, for example, of the heat, okay, with the air condition problems. Because if the temperature will go high, okay, I have to turn off everything, not to boil them up, okay? So I have such case on Friday. I was not administrating, but I was using some of our GPU cards system, and suddenly it stopped to be working. And I asked my colleague who is the administrator, and he told me, okay, but the air condition was broken. So he was really off that computer. Of course, he was not going there. He was just using some applications, as you can notice here. Just press the button remotely, and it was turned off. Okay, so it's, at least I'm happy that I don't have to bother with it. So, but if you want, and if you need for some cases to deal with the middleware, with the data and application by yourself, okay, you have infrastructure as a service. So you have a virtual system for you. But on the other hand, if, I don't know, you are developing in Java, for example, so why to bother with Java virtual machines, with, I don't know, some WebSphere servers and all that ugly stuff? Let other components to deal with. You just are doing with your application. But if you are a user of some applications, why to bother with installing it? Maybe you are just buying a software. And we are doing it as humans, okay? We are doing it, for example, using Google email system is a software as a service, okay? The email system at university in the past was like that. So everything was managed by university. And now nothing is managed by the university. So everything from the hardware to the software is running in the Google, by Google, okay? So why it is possible? Due to virtualization. So us as a service is a solution to different problems. For example, platform as a service, quite often used by students. Of course, it's nice that, but very often all these clouds have some amount of money for free, some extra for students. So very often you can use it for just a final project, for example, for free, because you have such capabilities, of course. So if you are, I don't stick with the Microsoft platform, you can use Microsoft Azure, whatever, maybe with Python. So Google, Heroku, and you don't have to install everything. It is running on Google, I don't know, Jupyter, for example, you can run on Google servers for free in some, let's say, amount of limitation when it is free. Of course, this is not the whole cloud. In practice, we are very often mixing models. For example, you can integrate humans in the loop, okay? For example, as audio to text. On the other hand, we as a university, as a project place at university, are now making services that ISR, so converts audio to the text automatically without humans. So, but also we will make some services like that. We are now working on the services for cleaning the data, the text data, okay? So because it requires human insight, it's impossible to clean any data automatically. So we will provide let's say, a service that is a mixture of software and the human being. So really, cloud services are not always hardware and software. Sometimes we have humans inside that are doing some stuff by hand, okay? Also, we could have different deployment models. I was showing you a private cloud, okay, that was owned or is owned by our university. I was talking about the public cloud, I mean, Amazon, Google, Windows. But very often we have a mixture of hybrid clouds, okay? So mixture of public and private clouds. It is very often due to some limits of the law that's stating that some data are sensitive and you as a company are not allowed to store it on the Google somewhere, and I don't know, in Russia, for example. So very often we are mixing things. Or we could have a community cloud, we have such cloud also at university that is available for all the universities in Poland, for example. So it provides and somehow resells the infrastructure to others. Why it is possible? Because virtualization is available on the market. How it is managed today, okay? In such huge data center as Google, even sometimes slightly larger than those I was showing to you at our university, of course, having access to that Xen user interface I was showing to you is not the best solution. Why? Because it will require me or my colleague inside that we have administration rights. Okay, so it is okay, but for very, very small private clouds. In practice, it is more automatized. Okay, one of the solutions, we have dozens of them, but one is quite popular nowadays because it is also, again, open source. Even the name suggests it's open source. It's an OpenStack, one of the it's one of the most popular, I think, but I haven't seen a real analysis of that. So this is my assumptions. And of course, OpenStack is much more than just virtual machines. It allows you to manage not just virtual machines, so that element I was talking to you, but even it allows you to manage bare metal. And even it allows you to manage things like containers, Dockers, Kubernetes, and that kind of stuff. But Kubernetes and Dockers, it will be the story for the next week, or maybe not the next week, or my next lecture. This is correct answer. But why it is possible? Why OpenStack allows such stuff? You notice, I hope that you notice that, or you can imagine that since I was able to change the amount of memory, change the CPU monitor from my application running on my host. So it is, the Xen and VMware equipped with API. So you can have an extra other software like OpenStack that allows you to access it. Okay, and it is free and built to manage all possible, or not maybe all the most popular solutions. So for you, it does really not matter that what is behind, what kind of the virtualization you are using, or maybe bare metal, or maybe para-virtualization or containers. Does not really matter. You can manage them automatically for any place. Okay, why it is possible? Because we have a lot of software behind it, and everything is done by communication, each piece of the software with the other. Okay, so this is a really collection of the large work of the different people. But what is important that you could have a just graphical user interface, mostly nowadays not native, but of course web-based one. But also we have a command lines, so you can just use it from the command line, which is a perfect interface, I think. Or you can have an app SDK in Python, so you can create an application that is managing a part of such system and adding new features. It's easy to add new features since we have APIs. Okay, so API to API some software and again and again. So it's growing and making it everything simple. Okay, so it could be seen really sophisticated because a lot of names, a lot of techniques. Yes, it is true if you want to understand all the details. On the other hand, it is ready to be used, and if it is installed, it is quite really easy to be used. How to start with that? Okay, so you can use it inside your private cloud. Okay. If you have such cloud, you can get an access to some external cloud. If you have only pay, you need money to do it. But if you want to do some small tests, there is a distribution of the OpenStack called MicroStack. And it's, of course, again, free, but it is devoted to the situation when you have let's say one small computer or two small computers.
So you can install it locally just for testing purposes, for training purposes. It is really nice. So if you have some spare time, which is hard in our lives, you can use it. So what is the cloud computing? From my point of view, it's nothing. It's just the way how we are using our modern off-the-shelf products and systems, okay? And everybody is a cloud computer user, everybody. If you are buying almost anything. A year ago, I have bought a system that monitors temperature in my greenhouse. And of course, it is cloud-based, okay? I could access the temperature, I could turn on or turn off the watering system from my mobile, through the cloud. Because everything is cloud-based nowadays. So you can really hard nowadays to buy anything that is not cloud-based. But because of virtualization, this is the magic we have, and standardization and layers, APIs, layers, open software. This is the magic that makes it possible, and it is running and running. So cloud standards nowadays are built into everything. So it's hard to build a cloud-free system. Okay, it's almost everything on the cloud, but I not yet finished. I want to advertise my next lecture. But before advertising my lecture, a short story, okay, that I hope will help you imagine why not virtualization is enough, why we need a next step. I mean the step of Dockers. What's the really problem of virtualization? In late 90s, when I was really firstly using, and I was really fascinated by virtual machines, and during my cooperation with one of my colleagues, I have such situation that he wants me to do something to help him with some ugly Microsoft environment. So I needed to have some testing environment just to build a small software that will do something. Okay, so I needed, he called me, okay, so I told him, give me a virtual machine. It was late 90s. And since it was Microsoft with some extra software inside, so it was 40 gigabytes, okay? So it was impossible to send by network as it would be possible today. So he drive to me by car with the external hard drive. But after, let's say, half hour, I was able to run the software and to work and test and develop a software on that virtual machines that was mimicking the real system he was in his company. So it was really fascinating, okay? Because without it, I would have to go there, and really it was the work for the company in the US, okay? So it was impossible for me to be in US in 1 hour, okay? So it is really perfect, because I could have a testing and development environment within 1 hour. But next, our cooperation became larger and larger. So next, I was doing something else for him. In the same, more or less, environment, but in a slightly different software. So he has given to me the next virtual machine. The next virtual machine, and each virtual machine was 40 gigabytes. Okay, they were slightly different. On one was that software, on the other software, but most of they were the same, because they were running on Windows with exactly the same code. So it was for me and it is still a loss of hard disk space. Why not share the same parts of virtual machines? It's a stupid idea to have the same code, the same bits on the hard disk, okay, twice, 3 times, 100 times, and just in that cloud environment maybe 1,000 times. So maybe layers and sharing of layers. This is a good idea. Okay. The other problem, if I change something or I have to run the virtual machine from the beginning, or maybe in the microservice architecture. Okay, so very soon, especially in case of web services, we have had two applications communicating with each other. So, okay, I could make a network. Okay, one virtual machine, the second virtual machine in my computer, the third virtual machine in my computer. My God, a lot of disk. And starting the virtual machine is like starting the real computer. It takes time. Okay, starting and it's running. Maybe the other solution could be better. Maybe I could install the software he requires. So I will need some instruction to do it, especially case, or maybe it will be much better to have just a script that will install me everything. And if the script will be available for all the software, that it will install the software and all its dependencies, wow, it will be nice. Why not? We are not having it. Yes, we are having it. Because Dockers, containers, Docker is one of the examples nowadays, the most popular. We'll see what will be in the future. Maybe it will change. We have also other solutions. So the containers are based on three elements. I have raised them on layers, hardware layers, disk layers, so we can share the same part of the operating system, based on scripts that automatize everything, and based on para-virtualization I was talking about. And this is our modern world, Dockers, okay? So Dockers and orchestration of Dockers, I mean, Kubernetes, an example of a real user interface for administrating Dockers, I mean, Rancher will be the next lecture subject. But I don't know when it will be. It is planned somewhere, I mean, 2 or 3 weeks. You can just check in Educacja CL system. So thank you very much for your attention and see you each other next time. Bye-bye.
Thank you. Have a good week.
Bye.
Thank you. Have a good day.